frozen in place, planets drifting slowly, the moon glowing above the horizon. Space looked peaceful because our eyes were weak. It looked empty because we were listening with the wrong senses. Then we built machines that could hear what human biology never could: radio telescopes, neutrino observatories, gravitational wave detectors, and space telescopes watching in wavelengths our eyes cannot see. Slowly, the silence began to crack. We heard dead stars ticking like clocks. We heard radio bursts crossing billions of light years. We detected ghost particles from violent galaxies. We heard black holes collide through ripples in spacetime itself. To be clear, there is still no confirmed evidence of an extraterrestrial civilization, no verified alien message, no decoded transmission from another intelligence. But the absence of proof is not the same as comfort, because the universe is full of signals, and we are still learning how to tell the difference between a dead star, a cosmic explosion, a machine, and something we do not yet have a name for. So tonight, we are not asking whether aliens are calling us. That is too simple. We are asking something darker. What does it mean that space is speaking at all? Alright, let's get into it. Number 10, the WOW. Signal on August 15, 1977. A radio telescope in Ohio heard something that has haunted astronomy ever since. The telescope was called Big Ear, and it belonged to Ohio State University. It was not glamorous. It did not look like the giant dishes people imagine when they think of deep space communication. But it was listening carefully, scanning the sky for narrowband radio signals as part of the search for extraterrestrial intelligence. A narrowband signal matters because nature usually produces radio noise spread across a range of frequencies. A very narrow signal can look more like technology. It can look like a transmitter. That does not mean it must be artificial. Still, it does make scientists pay attention, because if another civilization wanted to send a simple beacon across the galaxy, a narrowband radio signal would be one possible way to do it. A few days after the observation, astronomer Jerry Amen was reviewing the printed computer data when he saw something unusual: sequence 6EQUJ5. To most people, it would have looked like random characters on a page, but to Amen, those characters represented signal intensity. They showed that Big Ear had detected a strong radio signal, apparently from the direction of the constellation Sagittarius. The signal lasted for 72 seconds, which was exactly the amount of time Big Ear could observe one point in the sky, as Earth's rotation carried that region through the telescope's beam. Then it disappeared. Eamon circled the sequence on the printout and wrote one word in the margin: "Wow." That is how the WOW signal got its name, not because it explained anything, but because it refused to behave like ordinary noise. The most unsettling part is what happened next. Scientists looked again. They searched the same region of the sky. They tried to find a repeat. Nothing. No second pulse. No confirmation. No message. No source calmly announcing itself from the stars. Just one powerful signal, one time, and then decades of silence. Over the years, many explanations have been proposed. Maybe it was human interference. Maybe it was a reflected signal. Maybe it came from a natural astrophysical process we did not understand at the time. Some researchers have suggested possible links to hydrogen clouds or rare cosmic flares, but no explanation has become universally accepted as the final answer. That is what makes it dangerous as a story. It is easy to exaggerate the WOW signal. It is easy to call it an alien message. But science cannot honestly say that. The correct answer is colder and more frustrating. We do not know. Imagine walking through a dark forest with an old radio in your hand. For hours, there is only static. Then suddenly, a clean tone cuts through the noise. It is not a voice. It does not say your name. It does not explain itself. But it is strong, clear, and perfectly timed to make you stop moving. Then the static returns. You call back. Nothing answers. You wait all night. Nothing. You come back the next day, then the next year, then for decades. The forest remains silent, and eventually the silence becomes part of the signal. The WOW signal is terrifying because it sits between two nightmares. If it were artificial, then something spoke once and never spoke again. If it were natural, then the universe could produce signals that look disturbingly like something engineered. Either possibility is uncomfortable, because the real horror is not the word alien. The real horror is ambiguity. A door opened for 72 seconds, and humanity saw only darkness on the other side. Number 9. Fast radio bursts. Fast radio bursts are cosmic jump scares. They last only milliseconds, but some release an enormous amount of radio energy in that tiny slice of time. They flash across the universe, pass through intergalactic space, hit our telescopes, and disappear before a human nervous system could even register that something happened. The first fast radio burst was identified in 2007 by astronomers studying archived data from the Parkes Radio Telescope in Australia. Since then, many more have been detected by observatories around the world. Some appear only once, others repeat. Some come from galaxies billions of light years away. Their signals are stretched by the matter between galaxies, which tells astronomers they are not local glitches. They come from deep space. At first, no one knew what could produce them. A signal that lasts a few milliseconds should be small, weak, and easy to dismiss, but FRBs are not weak. They are like the universe snapping its fingers with enough force to be heard across cosmic history. One leading explanation involves magnetars. A magnetar is a type of neutron star, the collapsed core of a massive star that died in a supernova. Imagine taking more mass than the sun and crushing it into an object roughly the size of a city. Then give it a magnetic field trillions of times stronger than Earth's. That is the kind of object we are talking about. A magnetar is not simply a dead star. It is a corpse under pressure. Its crust can crack. Its magnetic field can twist. Its interior can shift in ways no laboratory on Earth can reproduce. Under extreme conditions, it may release blasts of energy powerful enough to create radio bursts detectable across enormous distances. In 2020, astronomers detected a radio bursting from a magnetar inside our own Milky Way. That discovery strengthened the case that at least some fast radio bursts are produced by magnetars, but some is not all. The FRB population is not simple. Some bursts repeat, some do not. Some show strange polarization. Some appear in unexpected environments. Every time scientists narrow the mystery, the data opens another door. That is why fast radio bursts remain unsettling. A mystery is easier when it has one shape. FRBs have many. They like hearing explosions in the distance and assuming they all come from the same battlefield. Then you investigate and realize some are lightning, some are collapsing buildings, some are engines, and some are still unidentified. The sound is real, but the source is not one thing. There is also something almost cruel about their timing. A fast radio burst can cross billions of light years, travel longer than complex life has existed on Earth, and arrive here as a blink shorter than a camera flash. If your telescope is not watching at the right moment, you miss it. If your instrument is not sensitive enough, it passes through history unnoticed. That should bother us. How many signals have crossed Earth before we built the tools to catch them? How many cosmic events shouted into the dark while dinosaurs walked beneath them? How many passed through the sky above ancient cities, above oceans, above battlefields, above sleeping humans who believed the stars were silent? Imagine sitting alone in a dark house at 3 in the morning. For 1,000th of a second, every light in the house flashes white. Then everything goes black again. You check the wiring. Nothing is wrong. You ask the neighbors. They saw it too. Then, miles away, another house flashes. Then another. No one knows what is causing it. That is what fast radio bursts feel like. Not a conversation, not a warning. More like the universe has nerves, and somewhere deep in the dark, something keeps twitching. Number 8. The repeating bursts. A single burst is strange. A repeating burst is worse. Repetition creates pattern, and pattern creates temptation. Human beings are built to notice rhythm. Footsteps in the hallway, knocks on a wall, a light blinking in the distance. Once something repeats, we stop treating it like random noise and start wondering whether something is behind it. One of the most important repeating fast radio bursts is FRB 121102. It was the first FRB source clearly shown to repeat, and that changed the entire field. Before repeaters were confirmed, some scientists thought FRBs might come from catastrophic events. One-time cosmic disasters that destroyed the source completely, a collision, a collapse, a final flare before death. But FRB 121102 came back, again and again. That meant at least some FRB sources survived their own outbursts. They are not simply exploding and vanishing. They are engines capable of producing repeated flashes across deep space. Because it repeated, astronomers were able to localize FRB 121102 to a host galaxy far beyond the Milky Way. That was a breakthrough. It confirmed that at least some of these signals were truly extragalactic, and it connected the source to an extreme environment with persistent radio emission. The mystery did not disappear. It became sharper. Then came FRB 2.1809116b, also known as FRB 18091c. This source became famous because its activity appeared to follow a roughly 16-day cycle. Active for a period, then quiet, then active again. That does not mean aliens. It may involve orbital motion in a binary system, precession, magnetar activity, or some other astrophysical mechanism. But it does mean nature can create signals with timing that feels uncomfortably organized. That is the unsettling part. No serious scientist should claim that repeating FRBs are alien transmitters. The evidence does not support that. But the fact that nature can produce repeating, structured, distant radio signals creates a serious problem for the search for intelligence. What is a beacon? A repeated signal. What is a pulsar? A repeated signal. What is a machine? A source of structured emission. What is a magnetar under extreme stress? Apparently, it can also be a source of structured emissions. The boundary between nature and technology is not as clean as we want it to be. Imagine standing on a dark beach and seeing lights flash offshore. 3 flashes, a pause, 3 flashes again. You think it must be a boat, a person, a signal. Then someone tells you it could be bioluminescent waves shaped by the tide. And maybe they are right. But the flashing continues, and some primitive part of your brain still whispers, someone is out there. Repeating FRBs is terrifying because they expose that weakness in us. We are pattern-seeking animals in a universe that produces patterns without caring what we think they mean. Physics does not need intention to look intentional. It only needs the right conditions. Still, the problem remains. If a real artificial signal ever arrives, it may not be obvious at first. It may hide inside the same category as natural repeaters. It may be dismissed as another strange dead star until the pattern becomes too precise, too persistent, too information-rich to ignore. And that is when the fear would begin. Not at the first detection, not at the first headline, but in the quiet room where scientists check the telescope, check the calibration, check the interference logs, check the math, and the signal remains. Because a repeating signal means something simple and terrible. Something is still there. Number 7. Gravitational waves from black holes. On September 14, 2015, Earth was stretched. Not by much. Less than the width of a proton across the length of a 4-kilometer detector. But enough to prove that space-time itself had moved. At 5:51 a.m. Eastern Time, the twin LIGO detectors in Hanford, Washington, and Livingston, Louisiana, detected a passing gravitational wave. The signal came from 2 black holes that had merged about 1.3 billion years ago. It was named GW150914, and it became the first direct detection of gravitational waves. This was not just another astronomical discovery. It was the moment humanity gained a new sense. Before that detection, astronomy depended mostly on light, visible light, radio waves, X-rays, gamma rays, infrared, and ultraviolet. Different forms of electromagnetic radiation, all telling us about the universe through photos. But gravitational waves are different. They are not light. They are ripples in the geometry of space-time itself. Einstein's general relativity predicted that a century earlier. Massive accelerating objects should disturb the fabric of space-time, sending ripples outward at the speed of light. But for decades, those ripples were too faint to detect directly. The universe was ringing, and we did not yet have an instrument sensitive enough to hear it. Then LIGO heard the chirp. The source was horrifying on a scale. 2 black holes, each dozen of times more massive than the sun, spiraled inward faster and faster. As they orbited each other, they lost energy through gravitational waves. The orbit tightened. The speed increased. Then, in the final fraction of a second, they merged into a single black hole. In that final moment, several solar masses worth of energy were released as gravitational waves, not as fire, not as light, as distortions in space-time. For a brief instant, the event produced more power in gravitational waves than all the stars in the observable universe produced in light. And by the time it reached Earth, 1.3 billion years later, it was almost nothing. A tiny change in distance. A whisper so faint that only one of the most precise instruments ever built could detect it. That contrast is what makes it terrifying. At the source, cosmic violence is beyond imagination. On Earth, a tremor in the measuring stick. The catastrophe was ancient, enormous, and nearly silent. Imagine building a bridge across a canyon and measuring every beam with perfect care. Then one morning, the canyon itself breathes. The bridge does not shake because something hit it. It shakes because geometry changes. That is what gravitational waves are. They are signals carried not through space, but by space. The existential horror is that these events were always happening. Black holes were merging before humans existed. Neutron stars were colliding before Earth had cities. Spacetime was rippling through our planet while we slept, fought, prayed, and believed the cosmos was quiet. We were not safe because nothing was happening. We were simply unable to perceive it. GW 150914 was the moment humanity grew a new ear, and the first thing that ear heard was two black holes eating each other in the dark. That should change how we understand silence. Silence does not mean peace. Silence can mean our instruments are primitive. The universe is not a stage where things happen. It is the instrument itself. And for billions of years, something has been striking it hard enough to make reality ring. Number 6. High-energy neutrinos every second. Trillions of neutrinos pass through your body. They come from the sun, from nuclear reactions, from cosmic rays striking the atmosphere, from dying stars, and from some of the most violent engines in the universe. You do not feel them because almost none of them interact with matter. They pass through you, through buildings, through mountains, and through the entire Earth as if the solid world were mostly a suggestion. That is why neutrinos are often called ghost particles. They are almost massless, electrically neutral, and extremely difficult to catch. A neutrino can cross light years of lead and still probably pass through untouched. To detect them, scientists must build enormous instruments and wait for the rare moment when one neutrino finally collides with something. One of the most extraordinary detectors ever built for this purpose is IceCube, buried deep in the ice at the South Pole. IceCube is not a telescope in the traditional sense. It does not look up with mirrors. It uses thousands of sensors embedded in Antarctic ice to watch for tiny flashes of light produced when neutrinos interact with matter. The idea is almost absurdly beautiful. To study the most elusive particles in the universe, scientists turned part of Antarctica into a detector, a frozen cathedral of sensors waiting in the dark. On September 22, 2017, IceCube detected a high-energy neutrino, now known as IceCube 110922A. After the detection, observatories around the world looked toward the same region of the sky. They found that the direction matched a flaring blazar called TXS 0506056. A blazar is an active galaxy with a supermassive black hole at its center, launching a jet pointed roughly toward Earth. That association was a major moment for multi-messenger astronomy. It suggested that a distant cosmic engine, powered by a supermassive black hole, may have accelerated particles to extreme energies and sent at least one neutrino across the universe to be caught beneath Antarctic ice. Science must be careful here. One event does not explain every high-energy neutrino. The connection involved probability, follow-up observations, and additional evidence, including earlier neutrino activity from the same direction. But even with caution, the implication is chilling. A black hole in a distant galaxy may have fired a ghost particle across cosmic space. That particle crossed unimaginable distance, passed through darkness, entered Earth, and finally died in ice beneath the South Pole. Imagine a bullet passing through your house without making a hole, through your body without pain, through the planet without slowing down, and then striking one atom in a hidden underground chamber, producing a tiny blue flash. Now imagine the gun was a supermassive black hole in another galaxy. That is high-energy neutrino astronomy. It tells us the universe is not only sending light, it is sending particles. Messengers that do not care about dust, gas, magnetic fields, or the walls we build between ourselves and the sky. Photons give us images. Neutrinos give us clues from places light may not escape cleanly. And the existential twist is simple. We live inside a cosmic firing range. Invisible particles from violent events cross Earth constantly. Most pass through without touching anything. A few are caught. Fewer still can be traced back to their source. The messages were always passing through us. We were just too solid, too blind, and too young to notice. So, when IceCube catches one, it is not just a detection. It is proof that the universe can send a messenger through your body and keep going, carrying a story from a monster so far away that human history is less than dust by comparison. Number 5. Pulsar glitches. Pulsars are dead stars that act like clocks, and that sentence should not feel comforting. A pulsar is a rotating neutron star, the collapsed core left behind after a massive star explodes. It sends beams of radiation from its magnetic poles, and if those beams sweep across Earth, we see pulses arriving with extraordinary regularity. Some pulsars are so precise that astronomers use them as cosmic timekeepers. Millisecond pulsars can rotate hundreds of times per second, producing pulses so stable they rival some of the best clocks humans have built. Networks of these pulsars are used in pulsar timing arrays, which search for subtle disturbances that may reveal gravitational waves from supermassive black hole systems. From far away, a pulsar can seem almost perfect, flash after flash, tick after tick, a lighthouse built from the corpse of a star, but sometimes the clock breaks. A pulsar glitch is a sudden change in the rotation rate of a neutron star. One of the most famous glitching pulsars is the Vela pulsar, which has been observed glitching many times since its discovery. These glitches are not random mistakes in a human instrument. They appear to be real physical events inside or around the neutron stars itself. That should disturb us, because neutron stars are already among the strangest objects in the universe. They compress more mass than the Sun into something roughly the size of a city. Their gravity is extreme. Their crust may be harder than any material on Earth. Their interiors may contain superfluid matter, where particles move in ways that do not resemble ordinary liquids at all. We cannot open a neutron star. We cannot drill into it. We cannot reproduce its interior in a laboratory. So, scientists infer what is happening by watching the timing of its pulses. Every flash is a clue from a sealed tomb. One leading idea is that glitches involve interactions between the star's solid crust and superfluid interior. The star gradually slows down over time, but parts of the interior may not slow down in the same way. Stress builds. Angular momentum shifts. Then, suddenly, the outer crust spins a little faster. From Earth, the dead star jumps. The clock stutters. Imagine listening to a grandfather clock in a dark hallway. For years, it has ticked perfectly. The rhythm is so stable that you begin to trust it more than your own heartbeat. Then, without warning, the clock ticks twice at once. The wall behind it cracks, and something inside the mechanism shifts. That is the feeling of a pulsar glitch. It is not a message. It is not a code. It is not evidence of intelligence. It is worse in a different way. It is evidence that even the most precise natural clocks in the galaxy carry hidden violence inside them. Pulsars remind us that order can be an illusion created by distance. From Earth, the pulses look clean and mathematical. But inside the star, matter is under pressures we can barely describe. The surface may look stable, while the interior is storing stress like a fault line before an earthquake. And when that stress breaks, the signal changes. That is why pulsar glitches belong in this countdown. They are not terrifying because they might be aliens. They are terrifying because they show how much of the universe is hidden behind regularity. A perfect rhythm can come from a damaged object. A reliable clock can be a corpse under strain. We like to imagine time as smooth and dependable. Pulsars tell us time can be measured by dead stars. Glitches tell us even dead stars can lose the beat. And if the most precise clocks in the galaxy can suddenly stutter, then maybe stability is not a law of nature. Maybe it is just what chaos looks like when you are standing far enough away. Number 4. The ultra-long radio transients. Some signals are terrifying because they happen too fast. Others are terrifying because they happen too slowly. Fast radio bursts last milliseconds. Pulsars can flash many times per second. Magnetars can erupt in sudden violence. But in recent years, astronomers have begun finding radio sources that do something far from strange. They pulse on timescales that feel wrong. Not milliseconds, not seconds. Sometimes for many minutes, sometimes longer. And that puts them in a category where the old explanations begin to strain. These objects are often described as long-period radio transients. That phrase sounds calm, but what it really means is this. Something in the galaxy is turning on and off in radio light, and it is doing it far more slowly than ordinary pulsars are supposed to. One especially strange example is ASCAP J9935 plus 2148. Observations reported in 2024 found that this source has a period of about 53.8 minutes. It does not simply blink in one clean way. It appears to switch between different emission states. Sometimes bright pulses lasting many seconds, sometimes weaker and shorter pulses, and sometimes long stretches of silence. That is not normal behavior for a standard radio pulsar. A typical pulsar is a rapidly rotating neutron star. It sends beams of radiation into space like a lighthouse. When that beam sweeps across Earth, we see a pulse. The timing of the pulse usually tells us how fast the star is spinning. Many pulsars rotate once every fraction of a second. Some rotate many times per second. So when astronomers see a radio source pulsing roughly once every 54 minutes, the question becomes uncomfortable. What exactly is rotating that slowly and still producing radio emission like this? It could be an unusual neutron star. It could involve a white dwarf. It could be a magnetar-like object operating in a regime we do not fully understand. Or it could represent a population of radio sources we have only just begun to uncover because our surveys were not built, historically, to notice them well. That last possibility is the disturbing one. Astronomy depends on classification. We survive the sky by naming it: star, planet, comet, pulsar, magnetar, black hole, white dwarf, supernova remnant. A name is not just a label, it is a cage. It keeps the unknown from spreading too far. But then something appears that does not fit neatly inside the cage. A radio source pulses too slowly for the familiar models. It changes states. It goes quietly. It is coming back. It behaves as if it belongs to a category that should have been obvious, except somehow we barely knew to look for it. That is what makes this ultra-long radio transients feel like cosmic horror. They are not necessarily the most violent signals in space. They are not as famous as the wow signal, not as explosive as fast radio bursts, not as dramatic as black holes merging. But they carry a quieter fear. The fear that the galaxy is full of phenomena hiding in plain sight, because our instruments were listening at the wrong rhythm. Imagine walking past an abandoned lighthouse every night. You think it is dead. The windows are black. The tower is silent. Then one night, just before dawn, it flashes once. You wait. Nothing happens. You leave. The next morning, someone tells you it flashes only once every hour, and sometimes not at all. The lighthouse was never dead. You were just not patient enough. That is the problem with slow signals. Human attention is built around human time. We notice seconds, minutes, days. But the universe does not care about our nervous systems. A signal could repeat once every hour, once every year, once every 1,000 years, and still be regular on cosmic terms. How many signals have we missed because they did not fit our schedules? How many cosmic lighthouses flash across the Milky Way once per century? How many strange radio sources turned on before telescopes existed, then went quiet, then waited patiently for a civilization that had not yet invented electricity? Every new survey does not merely answer questions. It creates new monsters. ASCAP, CHIME, Meerkat, FAST, and the next generation of radio telescopes are not just cleaning up the map. They are showing us that the map was never complete. And the more complete it becomes, the less comfortable it feels. Because if we can find a strange, slow, structured source inside our own galaxy only now, then the Milky Way is not a familiar neighborhood. It is a dark building where we have checked only a few rooms. The existential twist is brutal. Maybe the universe is full of signals that repeat too slowly for a human lifetime. Maybe there are patterns stretched across centuries that no single civilization survives long enough to recognize. Maybe the sky has been blinking at us since before language, but only now have we started to notice the first few flashes. The nightmare is not just that space sends signals. The nightmare is that we only hear the ones our machines happen to be ready for. Number 3, SETI candidate signals. Every serious SETI scientist lives with a dangerous kind of hope, not fantasy, not blind belief, not the cheap certainty of conspiracy theories. A disciplined hope. The hope that one day, buried inside radio noise, there will be something that cannot be explained as interference, satellites, aircraft, software, calibration error, or natural astrophysics. A signal that passes every test. A signal that comes back. A signal that forces the room to go quiet. Because if a true extraterrestrial signal ever appears, the first emotion will not be celebration. It will be suspicious. Scientists will check the telescope. They will check the clocks. They will check the receivers, the software, the satellites overhead, the aircraft logs, the nearby transmitters, the microwave ovens, the cables, the filters, and the possibility that some perfectly ordinary human machine has made the greatest discovery in history. That is the reality of SETI. It is not one dramatic moment where a computer screen suddenly prints, "Message received." It is a long war against false positives, a graveyard of candidates, signals that looked interesting, then collapsed under investigation, signals that raised eyebrows, then turned out to be interference, signals that reminded us how noisy Earth has become. One of the most famous modern examples is BLC-1, or Breakthrough Listen's Candidate 1. Breakthrough Listen detected it while observing Proxima Centauri with the Parkes Murray-Young Radio Telescope in Australia. That detail alone made the story feel electric. Proxima Centauri is the closest star to the Sun, just over 4 light-years away. It has at least one known planet, so when a narrow-band signal appeared from observations in that direction, it was impossible not to feel the emotional gravity of it. A nearby star, a narrow-band signal, a possible technosignature candidate. Those words were enough to make the imagination run ahead of the evidence. But science cannot afford imagination without discipline. Detailed analysis later found that BLC-1 was most likely local human-generated radio interference. Researchers identified similar signals and showed that the candidate did not survive the full process of elimination, so BLC-1 was not aliens. And that should have been comforting, but somehow it was not, because BLC-1 revealed how close the edge really is. For a brief moment, people had to imagine what it would mean if a signal from the nearest star system could not be dismissed. Not from a galaxy billions of light years away, not from some abstract coordinate in a telescope catalog, from the star next door, in cosmic terms. And that is where SETI becomes existential. A confirmed signal from another intelligence would not simply add a new fact to astronomy. It would cut human history in half, before detection and after detection. Before detection, humanity could still pretend that intelligence was a local accident. After detection, that idea would be dead. We have built our identity inside a silence. Every empire, every religion, every war, every scientific revolution, every love song, every extinction, every city lit up at night has happened under the assumption that Earth is the only known place where matter has opened its eyes and asked what the universe is. A confirmed SETI signal would not answer every question. It would create questions large enough to swallow civilization. How far away are they? How old is the signal? Are they still alive? Did they transmit intentionally? Did they notice us first? Are we hearing a civilization or only the automated remains of one? And perhaps the most disturbing question of all, what would it say about the universe if the first signal we ever found came from someone who is already gone? Imagine living your entire life in a locked house. You hear pipes, wind, insects, the ordinary sounds of an old building. Most noises have explanations. Then one night, someone knocks from the side of a wall you believed was solid. You do not know who they are. You do not know how long they have been there. You do not know what they want. You only know the house was never what you thought it was. That is why SETI candidate signals are terrifying, even when they turn out to be false. Each candidate is a rehearsal for the end of human isolation. Each false alarm forces scientists to practice the moment when Earth might stop being the only voice in the dark. And each false alarm teaches another uncomfortable lesson. Our own technology is now strange enough to impersonate the thing we are searching for. Earth is wrapped in radio noise. Satellites cross the sky, aircraft transmit, radar systems sweep, electronics leak. Human civilization has created a fog of signals around the planet, then built telescopes and asked the universe to whisper through it. Maybe the first obstacle to hearing aliens is not distance. Maybe it is us, our machines, our interference, our impatient interpretation, our desperate need for the universe to mean something. The first alien-looking thing we keep finding is our own reflection. But one day, a candidate may survive. One day, a signal may remain after the interference is removed, after the satellites are checked, after the telescope is tested, after the natural explanations fail. One day, the data may refuse to disappear. And that day would not feel like science fiction. It would feel like standing in the dark, hearing a knock again, and realizing that this time, it came from the other side. Number 2. Hypothetical technosignatures. A radio message is the version of contact we understand most easily. A voice in the dark, a beacon between stars, a narrow-band tone deliberately aimed at anyone advanced enough to listen. It feels cinematic because it feels human. We send messages, so we imagine others would send messages too. But an advanced civilization may not announce itself with a greeting. It may leak, it may glow, it may pollute, it may change the light of its star. That is the idea behind technosignatures, detectable signs of technology beyond Earth. Not proof that anyone has been found, because no confirmed technosignature has been detected, but a serious scientific category of things researchers can search for. Technosignatures could include radio transmissions, laser pulses, artificial atmospheric chemicals, waste heat, city lights, large structures in orbit, or unusual patterns in the light from a star or planet. Some ideas are near term, some are speculative, some are extremely difficult to detect with current instruments. But the logic behind them is simple and disturbing. Life changes a planet. Technology may change it even more. From far away, Earth would not look like a blue marble filled with human stories. It would look like data. Oxygen in the atmosphere, methane, water vapor, reflected light, maybe, with extremely advanced instruments, signs of artificial illumination or industrial chemicals. A distant observer would not see our faces. They would not hear our languages. They would not know our histories. They would see that something has altered the planet. That may be how we find someone else. Not through a conversation, but through contamination. This is a colder version of first contact. Not a message saying hello. Not a ship descending over a city. Not a dramatic announcement that we are not alone. Instead, a spectrum, a chemical imbalance. A planet whose atmosphere contains molecules that should not persist unless something keeps producing them. A star with an infrared excess that suggests waste heat. A pattern of dimming that looks strange enough to investigate. A technological footprint without a visible foot. That is somehow more disturbing than a voice, because a voice suggests presence. A technosignature may suggest absence. A civilization does not need to survive for its technology to leave evidence. Pollution can outlast governments. Space debris can outlast the people who launched it. A probe can keep transmitting after its makers are extinct. A megastructure, if such things exist, could become a ruin orbiting a star long after the hands that built it are dust. We may not find neighbors. We may find ruins, and ruins are worse, because ruins ask a question no greeting can ask. What happened to them? This is where technosignatures connect to the Fermi paradox. If intelligent life is possible, and if the galaxy is old, and if there are billions of planets, then where is everybody? Silence may mean life is rare. It may mean intelligence is rare. It may mean technology destroys itself. It may mean civilizations choose not to broadcast. It may mean we are looking in the wrong way. But if we find a technosignature from a dead civilization, the question changes. It is no longer, are we alone? It becomes, are we early, lucky, or next? Imagine walking through a dark forest and finding not a living village, but an abandoned city. The fires are cold. The doors are open. There are tools on the ground. There are towers still standing. Something intelligent was here, but it is not here now. At first, that seems less frightening than meeting the builders. Then you realize the city is a warning. A technosignature could be a lighthouse, or it could be a tombstone. From 1,000 light years away, the two might look almost the same. This is why the search must be careful. It is tempting to look at any strange star or unusual signal and imagine alien engineering. But science demands restraint. Most anomalies have natural explanations. Dust can dim a star. Instrumental effects can mimic patterns. Chemistry can surprise us. Planets can behave in unexpected ways. The terrifying part is not that every anomaly is a civilization. The terrifying part is that one might be. And if one is, we may not understand it at first. It may not look like a message because it was never meant for us. It may be industrial noise, waste heat, atmospheric damage, or the fading signature of a project completed long before humans existed. That is a different kind of loneliness. Not the loneliness of being alone in the universe, the loneliness of arriving late. Number one, what if something answers? The most terrifying signal from space is not the one we have already detected. It is the one that might arrive tomorrow. Not a fast radio burst. Not a pulsar glitch. Not a gravitational wave from black holes. Not a neutrino from a blazar. Those are frightening because they reveal a universe more violent and stranger than our senses were built to understand. But a reply would be different. A reply would not just reveal something about the universe. It would reveal something about us. A confirmed, repeatable, information-bearing signal from another technology would be the most important discovery in human history. Every test would have to survive. It would have to be checked against interference, satellites, aircraft, software errors, natural astrophysical sources, an all-known way humans fool themselves. It would need independent confirmation from different observatories. It would need time, caution, skepticism, and probably fear. But suppose it survives. Suppose the signal remains. Suppose the math is checked, the telescope is checked, the source is confirmed, and the conclusion becomes unavoidable. Something beyond Earth has transmitted information. The first thing that dies would be human solitude, not loneliness in the emotional sense. Something older, something built into the way our species understands itself. We are used to being the only known minds in the cosmos. We may not say it out loud, but nearly every human story assumes it. We are the observers. We are the questioners. We are the ones looking out. A reply would end that forever. After that moment, humanity would never again live in the same universe. The stars would not change position. The laws of physics would not rewrite themselves. The sun would still rise. People would still go to work. Cities would still make noise. But underneath everything, the foundation would be gone. Because we would know the dark has listeners. The signal might be simple. A repeating mathematical sequence, a narrowband carrier wave, a pulse pattern that encodes prime numbers, a structured data stream, or something we cannot decode at all but can still recognize as artificial, because nature does not produce that kind of compression, repetition, or information density. It might not say we come in peace. It might not say anything we understand. It may only prove that somewhere else, matter became organized enough to build instruments, aim them at the sky, and transmit. That alone would be enough to break history. And then the questions would begin. How far away are they? If the signal came from 50 light years away, it was sent 50 years ago. If we answered, they would not receive our reply for another 50 years. A conversation would take a century per exchange. If the signal came from 1,000 light years away, then we might be hearing a civilization from the time of medieval Earth. If it came from 10,000 light years away, we might be hearing ghosts. That is one of the deepest horrors of interstellar contact. A signal does not guarantee a living sender. It only proves that at some point, someone transmitted. We may receive a message from a civilization that no longer exists. We may spend generations decoding the voice of the dead. And if the message is clearly directed at us, the fear becomes sharper. Because that would mean they noticed Earth, not humanity, necessarily. Maybe they detected oxygen in our atmosphere. Maybe they saw industrial chemicals. Maybe they noticed radio leakage. Maybe they detected radar. Maybe they found our planet long before we knew how exposed we were. For more than a century, Earth has been leaking electromagnetic signals into space. Most ordinary broadcasts become extremely weak with distance, and detecting them across interstellar space would be difficult. But powerful radar signals, intentional transmissions, and planetary atmospheric signatures are different questions. The details matter. We are not simply shouting clearly to the whole galaxy, but we are also not invisible. Earth is a planet with chemistry out of equilibrium, technological activity on its surface, and a young civilization learning to light up the dark. To a sufficiently advanced observer with the right instruments, we might not be hidden at all. That is the dark forest fear. Not that aliens are automatically hostile. That is too simple. The deeper fear is that we do not know the rules of the environment we are entering. A child lighting a match in a forest at night does not know what the light attracts. If something answers us, then the campfire has been seen. And then comes the most human problem. Who replies? A signal from another civilization would not belong to one country. It would not belong to one telescope team, one government, one corporation, one religion, or one generation. It would belong to Earth. But Earth has never behaved like one mind. We cannot agree on borders. We cannot agree on resources. We cannot agree on climate, history, truth, or what kind of future we want. And suddenly, under the cold attention of another intelligence, we would be asked to speak as a species. That may be the most terrifying part of all. Not what they are, what we are. First contact would hold up a mirror. It would ask whether humanity is mature enough to enter a conversation older than nations and wider than all our wars. It would ask whether intelligence is wisdom or merely a brief fever that appears on planets before burning itself out. Imagine being a child hiding in a dark house. For years, you believed the house was empty. You hear creaks in the walls, static in the wires, wind pressing against the windows. Then one night, you whisper into the hallway, "Is anyone there?" At first, nothing. Then, from far away, Something whispers back, not loudly, not angrily, just clearly enough that you know the house was never empty. The silence of the universe is terrifying because it suggests we may be alone. But an answer may be worse, because an answer means we were never alone. It means all our history unfolded under a sky that may have had witnesses. It means the cosmic dark was not empty, it was occupied, and if the reply is old, distant, or incomprehensible, it may not bring comfort. It may only deepen the mystery. It may tell us that intelligence exists, but not that it survives. It may prove that civilizations can rise, but not that they endure. It may be a greeting, a warning, an archive, an accident, or the last automated signal from a world that destroyed itself before the message arrived. That is why this is number one. Because every other signal on this list tells us the universe is active, violent, strange, unfinished. But a reply would tell us something more personal. It would tell us we have been promoted from observers to participants. And participation is dangerous. The universe may not need us to introduce ourselves. Our atmosphere, our technology, our probes, our transmissions, our chemical fingerprints, our expanding sphere of influence may already be part of the data. We may already be visible in ways we barely understand. So, if something answers, we will learn one fact immediately. The cosmic silence was not empty. It was waiting. I'll be sharing more similar videos in the future, so subscribe to stay tuned.